All right, so let's continue with what we were talking about yesterday. Yesterday was just kind of like a little intro to circles and stuff like that. Let's see where I left off. I showed you an arc, right? Did we talk about that? We did arc yesterday. Yeah? All right, let's do this one. It's a theorem. It says, I'm not going to write it down. I'll just use the picture to describe it. But let's read it first, okay? It says, if a radius, you know what a radius is, right? Is perpendicular to a chord in a circle. So let's draw that. Say what? Let's keep it on today. Can you see it? You can see it, right? Keeping the light on might help you stay awake a little bit better. Do you think? No?
No.
You don't think it's a matter of just it being darker in here? All right, so first thing I'm going to do, almost all the time, when I do a circle, I put this point. What do you think that point is? It's the center of the circle. I'll tell you what I'm going to do. I'm going to copy this so I don't have to draw that center. Copy it. Okay. What did I say? If a radius is perpendicular to a chord in a circle. So let's draw a radius. Where do you want to draw it? You want to draw it straight down like that? You want to draw it straight across or just some kind of random angle? Straight across. I heard straight across first. All right, so there's a radius. I could have drawn it anywhere on that circle, correct? But what did I just say the theorem said? If a radius is what? Perpendicular to a chord, all right? So does that mean I can just draw a chord just any old way like that? No, because that radius has to be what? Perpendicular to that chord. All right. Would you agree that that's true? Well, it's true if what? That's a right angle. Then it's perpendicular. Agreed? All right. And it looks like a right angle, doesn't it? Yeah. So what's true about it? If that radius right there is perpendicular to this chord, what do you think that radius does to that chord? We can just kind of maybe look at it. Exactly right. Okay, it bisects that chord. So, see this point where they intersect each other? It's not just any old point of intersection, is it? It's an intersection that bisects that chord. So from there to there, do I use letters? Yeah, let's use letters. A, C, and B. That point is D. This point is O. A lot of times they make the center of the circle O. Don't know why, but they do. So that's what we'll do. Now, I go through in my notes a little proof on this. I don't think... Yeah, we're not really going to go through that. We're just going to say what is true, all right? So that means that AD and what? BD are equal to each other, all right? It bisects it, which means D is the what of AB? The midpoint. Everybody got that? Does that mean this radius is being bisected? No, all right? So for instance, let's use another color. What if I had a chord that was not perpendicular to that, like from there to there? See that yellow one right there? Is that yellow one being bisected? No, just because it goes through the radius does not mean it's being bisected. That little bit right there looks pretty much shorter than this one right here, doesn't it? All right. So the only way that you're going to bisect this radius right here, the only way that the chord is being bisected by the radius, I should say, is if, it's perpendicular. Would you agree? All right, so like if I went like this, does it bisect that yellow chord right there? No, only when it's perpendicular. We good? Good oak. All right, here's another one. By the way, you know what they're going to do. I think we are going to do an example. Yeah, we'll do example a little bit. But you know what they're going to do, right? They're going to give you this line segment and ask you this line segment, or they'll give you this AD and ask for the whole thing, or they'll give it to you like, make one of them like 3x plus 1 and the other 5x minus 2 and set them equal. You can do stuff like that. But also, what else do you think they could do with this? You got a right angle, don't you? They could, right? So that would be a radius as well, wouldn't it? All right. So they might do some stuff with a right triangle, right? Give you certain sides, maybe tell you what the radius is, tell you this, you got to find that, or they'll tell you this part right there, you got to find that. Maybe using Pythagorean theorem, right? Maybe there's a situation, I don't recall off the top of my head, but maybe there's a situation where you have a 45-45 90, a 30-60 90. Would you agree? Yeah, there's a lot that they could ask you on that. So we'll wait till we get to the example, but let's do another thing. All right. All right, here's another circle. Here's what this one says. It says, if a radius bisects a chord, it's kind of like the opposite of what we just said, isn't it? All right. So if a radius bisects a chord, let's go back to that other picture. We'll stick with that one. We don't need this thing right here. Does this radius bisect that chord? Huh? Yeah, the radius OC, does it bisect this chord AB? Yeah, absolutely. Okay, so it does. So that's what this next theorem says. If a radius bisects a chord that is not the diameter, is this chord not the diameter? Yeah, okay. So it's not the diameter, then it's perpendicular. It's the converse of it. Remember that word? We use that word a lot, right? It's kind of like you're taking the if and the then and you're switching it. So this one says, if it's perpendicular, then that radius bisects the chord. Got it? This one says, if the radius bisects the chord, then it's what? Perpendicular. Make sense? So it's kind of the same thing. It kind of, all right? Except the if part and the then part are just switched. So if this radius, watch, if OC is perpendicular to AB, then OC bisects AB. So that's what that first theorem that we talked about says. Everybody see that? So if they're perpendicular, then the radius bisects the chord. What does the second theorem say? It basically says if OC bisects what? AB, then what must be true? OC must be perpendicular to AB. Should put little line segments over top of these. Boom, boom, boom. I can't hear you. This one right here? Perpendicular. I wrote it as I said it. You didn't hear me say it? I said then OC is perpendicular to AB, and I wrote that little symbol right there. So that's perpendicular. All right? See the difference between the two? They're kind of the same, but they're different. All right? So that's the first two theorems. All right, got one more theorem, then we're going to do an example, and then we'll do some more theorems. Isn't that exciting? Yes, it's exciting. All right, let's see what this one says. This one's kind of not that super, I don't know. I could say the word important, maybe. I don't know. Let's just do it. It says the line in the plane of a circle that's a perpendicular bisector. So basically it says, if you have a perpendicular bisector of a chord, it contains the center of the circle. So, watch this. It says the line in the plane of a circle, that is a perpendicular bisector. So I'm not just talking about a radius this time. Watch. I'm talking about a line. Let me make sure it goes through there. Okay? So if this line And how do I know it's a line? Because I got arrows on the end, keeps going through. Is it necessarily a diameter? No, the diameter would start and stop on the circle, wouldn't it? Okay, so this is a line, keeps on going forever. It says if that line is a perpendicular bisector of a chord, so let's draw a chord. So you know, if I make that chord, now I could have drawn a chord any old way. I could have drawn a chord like that, but is that a perpendicular bisector? No, it's not perpendicular, is it? Because it doesn't make a right angle. But this, it's perpendicular and it's a bisector. Agreed? Right? Because we said, because this would be the radius, right? From here to here, not talking about the whole line, but from here to here would be a radius. So if it's perpendicular to this, then it would bisect it. All right, so what does this say? It basically just says, if this is true, then that line contains the center of the circle. All right, which means this. Let's do another color here. What if I drew another line that's perpendicular to the chord? Would you agree that that blue line looks perpendicular to that chord right here? Yes? But is that bisecting it? No. So that means the blue line doesn't go through the what? Not middle. We never said middle. What is it called? It's the center. It's the center of the circle. Okay? So this line right here, it could be perpendicular to the chord, but it definitely doesn't bisect it, does it? See that? Because that little space right there, that little line segment is definitely smaller than that one. So it doesn't bisect it, but it is perpendicular. But that means if it doesn't bisect it, it doesn't go through what? The center of the circle. So that's what they're saying on that one. All right? So that's kind of a weird one, but that's okay. Let's do another. Well, let's do an example. This is our example. So let's just draw it just the way we did it earlier. All right? There's a radius, and there is a chord that's perpendicular. All right. So it's perpendicular right there. And they do this. I'm going to do this in a different color. They use a dotted line in the book. So if you look in the book, they use a dotted line. I'm just going to do a color, make that green. Everybody with me? It says, find the diameter. Oh, by the way, I don't think I told you how to name a circle, did I? I don't think I did. So if that's point O right there, all right, like I said, a lot of times on circles, they call the middle one point O. Don't know why, but they do. Here's how you do a circle. You know how we did like angle, ABC? We did like triangle, DEF. We've done line segment, AB, right? All that stuff. Okay. We have a symbol. These are all symbols, but we have a symbol to represent a circle. Parallelogram. Remember parallelogram? Look like this. I'm just trying to think of other ones that we've had. We've had a bunch of symbols. Well, we have a symbol for a circle. Here it is. It's a circle. How about that? Amazing, isn't it? With a little dot in the middle. That right there is a symbol that means what? Circle. All right? So I tell you what, let's not make this an O, because then I got too many O's all over the place, because that looks like an O, doesn't it? Let's just call it X. All right? So what would I name this circle? What would I name it? Circle what? Circle X. That's right. We use the center, okay? That's all we need to know to name the circle, right? You know how to name a triangle, right? The vertices, triangle ABC, DEF, whatever the letters are. To name a circle, you use the center, and then it's just a point, and then that's how we name it. This right here means what? Circle X. Got that? All right, write it down. Write the stuff I'm writing down so you can remember that. All right, so enough of that. What about this? It says, find the diameter of circle X. Find the diameter. Find the diameter. Okay, of circle, that's how you do a circle, X. All right, if all this stuff is true. So they tell you that, I'll put the letters in here. Actually, let's turn this back into an O because they use O for this. All right. It's not a 0, it's an O, it's a letter. So they want you to find, or they tell you that OD is 3 inches. And they also tell you that AB is 8 inches. AB is 8 inches. All right? And you got to find the diameter. So tell me something about the diameter and the radius. Tell me something about the diameter and the radius. What's the diameter compared to the radius? Yeah, it's 2 times. It's twice as much, okay? Everybody with me on that? All right. So let's fill in the stuff. Smart, you have a question? You said what is what? You got it? Okay, OD is 3 inches, so this part right there is just a 3. AB is 8 inches. Let's do this. Let's not put the 8 in there. Let's think a little bit before I put the number in there. What is it? 4. That's right. This would be a 4, wouldn't it? You everybody see that? Why? Because if it's perpendicular, then what happens? That and that are equal to each other. We just talked about it. That was our first theorem, okay? So these would be equal to each other. That would be 4. This would be 4. But which one do you think I really care about here? This top one right here, all right? Now, without any math at all, if you remember your Pythagorean triples, what is OA equal to? Now, they don't ask you for OA, do they? But we're going to use OA to find something else, all right? So OA is what? It's 5. How'd you know that? Yeah, it's Pythagorean triple, 3, 4, 5. Okay? If you didn't remember that, you should remember 3, 4, 5, though, shouldn't you? That's the easiest one to remember, okay? So there's a 3, there's a 4. The hypotenuse will be 5. That's why it's nice to know Pythagorean triple. If you didn't know Pythagorean triple, what would you end up doing? You'd end up doing this stuff. Do you really want to do all that stuff? No. All right? I mean, you can, okay? And you do the math, and what are you going to come up with? You're going to come up with 5, and that's a 5 right there. But it's nice to know 3, 4, 5. Does that help me find the diameter? Absolutely, because what is the 5? The OA is the what? It's the radius of the circle, isn't it? And what do they ask you to find? The diameter. So how do we find the diameter? That's it. You just go, diameter is twice the radius. I just found the radius, which is 5, so what's the diameter? It's 10. And this is all in inches, so what's the diameter? 10 what? Inches. And there you go. Super easy. No. It's not squared. I'm not finding area. Area is squared. Okay, if I'm just finding a length, the diameter is just a length. Now, if you wanted to actually see the diameter, where would it be? It would be to there, wouldn't it? Okay? So that whole thing right there is 10. But you didn't really have to draw it though, did you? All right, you can kind of visualize it. So the radius is 5, the diameter is 10. It's not inches squared. Why? Because it's not area. The only thing that's inches squared or centimeters squared or anything squared is when you're finding the area. We're not finding the area. All we're doing is finding a length. How far is it? From here to here, that's 10. Make sense? Yeah, it's not too bad. We got one more theorem and then a couple examples and we'll be done. Let's do this theorem. Let's put a circle here. Actually, we're going to put 2 circles here. So I'm going to make this one just a little bit smaller. You know how we had congruent triangles? What did that mean, congruent triangles? They were exactly the same. So guess what? Watch what I'm going to do. I'm going to copy this and I'm going to paste it. I'm going to move it. Well, I thought I did. Let's try it again. Copy it and paste it. There we go. So if I copied and pasted, what do you think is true about these 2 circles? Why didn't it? I probably didn't grab the center. Copy, paste. There we go. Say that again. I'm sorry. They're exactly the same, which means they are congruent. So these circles are congruent circles. All right? In order for them to be congruent circles, they have to have the same what? Radius. That's it, okay? If they have the same radius, then they're congruent circles. Make sense? Okay? Because if the radius was smaller, then this circle would be smaller. If the radius was bigger, then this circle would be bigger. Yeah? Okay. So let's keep that in mind. So, incongruent circles, it says, two chords are congruent if and only if they are equidistant from the center. All right, so let's do this. Say that again. I'll read it again. In congruent circles, right, which we have right here, two chords are congruent if and only if they are equidistant from the center. So let's draw a couple chords. Let's draw a chord right here. It says two chords are congruent. So guess what I'm going to do with this chord? I'm going to copy and paste that one. I'm going to put it over here, but I'm going to change the angle, make it look a little fancier. Let's just change it some weird angle like that. But then what am I going to have to do? In order for it to be a chord, I need to make sure the endpoints match up. Would you agree those two chords are equal? Yeah, because how do you know those chords are equal? Because what did I do? I copied and pasted. Everybody got it? All right, so those chords are equal to each other. I made sure they were. All right, so what does this thing say? In congruent circles, two chords are congruent if they are equidistant from the center. What does that mean? The same distance to the center. So how do I find the distance from this chord to the center? Is that the distance from there to there? Is that the distance? Is that the distance? Where do you think the distance is? We've talked about this before. All the way to the other circle, that's the distance? Right there? That's the distance? What about that? That would be a different distance. This would be a different distance. Okay, stop saying straight down. We talked about this before. Perpendicular, yes. That's what I'm looking for. It's the perpendicular distance. Okay, so when I say what is the distance from a point to a line or a line segment, it's what? It's not straight down, because look at this one. What's the distance from this point to this chord? Is it straight down? No. What is it? It's perpendicular. All right, so watch this. If I go, now I got to eyeball it. That looks perpendicular about right there. Do you see that? So this distance will equal this distance if these two chords are equal to each other. Anybody watching? I'm pointing stuff, I'm talking, and there I see tops of heads. That's all I see. So look, if this chord is equal to this one, let's mark these. All right, so we'll call this A, B. We'll call this C, D. We'll call this X and Y. Is that all right? All right, so let's start off. Let's do this in white instead of red. Watch this. If AB is equal to CD, all right? And they were. How did you know they were? I copied and pasted. I made sure they were equal, okay? So I told you that AB and CD were equal to each other. Agreed? All right. So what is the distance then from this point? I guess we need some other letters here too, don't we? I don't know. What do you want to use? W and Z. All right. So if AB is equal to CD, the distance means they're perpendicular. Agreed? All right. Excuse me. So if those two chords are equal, then the distance to the center is equal, which means XW is going to equal what? YZ. You okay with that? So if I know that AB and CD are equal to each other, the distance from the center to that chord is going to equal the distance of this one to here. Watch this. I could, let's copy and paste that, and let's change the angle a little bit. Let's put it up here like that. It's the same. That chord's the same distance, isn't it? So watch this. If I went from the center perpendicular to that chord, guess what? It's going to be the same distance as this, isn't it? Everybody see that? So if I make that perpendicular, look, that and that are equal, and it's equal to that one as well. Make sense? All right. So that's basically what that theorem is saying. So let's do a couple examples, and we'll be done. When do we get out of here? Don't I ask that every Wednesday? Seems like it. 28. Oh, okay. I got some time there. Write it down. Write her down. All right, here we go. Let's do, yeah. Whoops. Let me go back. I could just, too worried about copying and pasting. Let's just make another circle, okay? Make it, oops, don't want it red though. Want it white. And let's put a center right there. There we go. And let's copy that one. All right, there we go. So I got two circles, and they're congruent circles. Yeah, I did not say in my notes that they were congruent, but they should be congruent to each other. All right, so here we go. Let's make a chord there. Hold up, let me take a look. If CD equals HI, okay, CE, okay. So let's do, I'm going to copy and paste that. I'm going to put this one over here. I'm going to twist it a little bit. I'm not changing the length of it, okay? Just keeping it the same length. Oops. We'll put that about right there. All right. And now, watch what I'm going to do. Let's do this in a different color. I'm going to find the distance between that center and that chord right there. So I'm going to go perpendicular to that, and I'm going to go perpendicular to that. Agreed? And you know what I did? I went all the way through. So let's go all the way through. Still perpendicular to it, but I went all the way through it. All right, so I did tell you that that's perpendicular and that's perpendicular. All right, I think that's my picture. Let's put some letters in here. A, B, C, D, E. So A, B, C, D, and E. E is that point where they intersect right there. And this is H. Just went right in order. I, J. Well, there's no K. There's F and G. Sorry, started too late. F and G. There we go. This is an I. It doesn't look like an I. There we go. All right, I think I got everything. So now, here's what they ask you to do. It says find A, B, and GF. A, B, and GF. If, now here's what they tell you. Okay, you don't know this. They're asking you to find those two things. But here's what they tell you. They say if CD equals HI, and they also tell you that CE equals HJ, and they also tell you that AB is equal to 5y minus 3. They also tell you that GF is equal to 2y plus 9. I told you they'd probably put some letters in there, right? You got to solve for whatever they ask you to solve for. All right, so let's write some stuff down that we know. Put in a different color. CD and HI are equal to each other. CD. So that's a radius, and that's a radius. So what's true about these two circles? If they both have the same radius right here, that means they're what? Congruent circles, okay? Everybody good with that? All right. They also tell you that CE, this little bit from right here, I'll just mark that. They also tell you that CE equals HJ, that one right there. So what does that mean about this little dinky part right here? That little part right there needs to be equal to this as well. Remember, because both radius are equal, if I take away two equal things, you're going to be left with two equal things, all right? So that's what you know. They tell you AB and, well, they don't exactly tell you what AB and GF are, but you know you're going to do something with this, all right? So watch what we have. We have so what's true about AB and GF in this situation then? If this is perpendicular to the radius, right? If it's perpendicular to the radius, then this AB, this chord, must be what? Equal to this chord, all right? Because the triangles or the circles are congruent to each other. The radii, the radius is equal, right? That must mean that this chord and this chord are equal to each other. So all that just to know that AB and GF are equal. All right. Now it's actually kind of simple. Now we just do math. All right. So what do I do with AB and GF? What do I say? Set them equal. That's right. Let's set them equal. All right. So let's do it. Now it should be kind of easy. 5y minus 3 equals what? 2y plus 9. Okay. Because if they're congruent circles and the chords are equal to each other, I'm sorry, the radius are equal to each other, they're congruent circles, it's perpendicular, right? If it's perpendicular, then these chords are equal, then they are the same, all right? Because one of the earlier theorems that we talked about. All right, so now that we know that, we got all that out of the way, that AB and GF are equal to each other, we can set them equal to each other, and now we can just solve for y. So subtract 2y from both sides. Done this a million times. Add a 3 to both sides. We get 3y equals what? 12. Y is 4. But they don't ask for y. What do they ask for? For AB. So let's put it in here. So it's going to be 5 times 4 minus 3. 5 times 4 is 20. Minus 3 is 17. This should be 17 as well, shouldn't it? Okay, because they're equal to each other. Let's see if it is. Put a 4 in for this. So it's 2 times 4 plus 9. That's 8 plus 9 is also 17. Yep, sure enough, they are equal to each other. And there you go. That's the length of AB, and that's the length of GF, and that's what they ask you to solve for, isn't it? They said find AB and find GF. If you wanted to get a little fancier, they could also ask you to find AE. What would AE be equal to? What is it? 8.5, 8.5, right? How'd you get 8.5? Where'd that come from? Yeah, you know the whole thing's 17. You divide that by 2. What's 17 divided by 2? It's 8.5 or 8.5. So that's 8.5. So is that. What about these down here? Going to be the same thing, right? Because the two chords are equal. All right, so that's stuff that you could find, isn't it? Yeah, that's good enough. Let's do one more. You ready? Oops, why did I keep doing that? Did I not copy it from before? Oh, it's just silly. Why don't I do things I'm thinking of doing? Let's just get rid of this so I can grab this. Grab that. Now I can copy it. All right, there we go. Let's make it a little bit bigger because I'm only going to use one circle on this one. All right, here we go. Oh, it's a bunch of stuff. A bunch of stuff on this one. So that goes up here like this, that radius. This radius goes down here like this. Then you got a chord like this. Then you got another chord like this. Okay. And let's put some letters in here. Lots of letters. A, B, and D. This part right there is H. This is C. This is G, F, E. And this one is J. And they tell you that that's perpendicular. And I believe they also tell you that this is perpendicular. I didn't write that on my notes, but I think that's true. Who's got their book open to example 3? Did they put perpendicular things on both of those? No? Okay. All right, here's what they ask you to do. So they don't put perpendicular. I think we can conclude after I write some stuff down that they are perpendicular. Let's see, find CH. So we're finding CH and HB. So that's what we're looking for. That's going to be our answer. Whatever the answer to CH is and HB. Here's what they tell you. They tell you if AD equals GE, and that equals 10 centimeters. Alrighty. So watch, AD and GE, they're equal to each other, correct? So they got equal chords. And did they not tell you that that's... Let me get my book. How much time do we got? 28, is that what you said? Oh, 1 minute? Oh, we don't have time to do that. There's probably a reason, I can't think of it off the top of my head, that that's perpendicular. But you could probably assume that, couldn't you? All right, so we'll do that. That's terrible to do, but that's okay. And AD and GE are 10. So what does that mean? Let's go down here. So if AD and GE are both 10, what do you think this does to that chord? Bisects it, right? So if GE is 10, what's this little bit right there? That's 5. What's this little bit right there? That's 5. Actually, I don't even care about that. I think they... I should have drawn this a little more accurately. Yeah, I should have gone to there. This is supposed to go through the center. I should have drawn it a little more accurately. I'm running out of time. I've already run out of time. I think they tell you something else. Did they tell you this is 13?
Yeah, they say.
Okay, I was going to say, you can't do this if you didn't know that. So that's 13. So what do you think? And this is 5 right there. So what do you think it is from here to here? That's 12. And that's C. Where's CH? Because 5, 12, 13. It's Pythagorean triple. And then... Yeah, see, this is supposed to go through the center. I kind of messed it up when I drew it. But if that's 12, that little bit right there is going to be 12 as well. There's your CH, and where's your HB? HB would be what? The whole thing is 13, so what's that little bit right there? That would be a 1. All right, sorry about that. Remember that whole thing's 13 because that's 13. And again, I drew it bad. This should have gone through the center, right? So it should have connected here. But there you go. So one is 12, CH is 12, and HB is that. So let's do 10 to 24. Sorry about the confusion on that last one. So 10 to 24, it's page 348. Page 348. And it's section 8.1. Section 8.1. All right, there it is. It'll be on the YouTube. It's just 8.1, just 8.1.